So here we are at our second calculus lesson. We are finding limits. And when I say finding limits, I actually mean estimating limits. So if you take a look at our objectives here, number one, we're going to estimate limits both graphically and numerically. If you did those 3 warm-up questions, you got a preview of what that is all about. In our next lesson, in 2-3, essentially, we will learn how to analytically find the value of a limit. But right now, we're going to kind of get a good grasp of what the heck a limit is by just looking at graphs and looking at table of values. Our second objective is about, hey, well, sometimes those limits actually can't exist. I try to evaluate it. I don't actually get a value for 3 particular reasons, and I want to know what those 3 reasons are. And over there on the right-hand side, don't let it scare you. You just got a small collection of problems from the book. Okay, so let's start by taking a look at those warm-up questions. First one, without a calculator, evaluate f of x is equal to the sine x over x when x is equal to 0. All right, the sine x over x, what an interesting function. But as far as calculus is concerned, it's kind of a big deal. All right, so let's actually write something down over here. Sine x over x. Well, like I could just look at this and see if I were to plug in 0, I can see that there is an x on the bottom. I already know it's going to be undefined. There's 0 on the bottom. I'm not allowed to divide by 0. But we learned in Algebra 2 specifically that when I go to divide by 0, it's not as simple as just saying it's undefined, because some complicated things could possibly happen, right? So we know that, hey, sure, absolutely, without a doubt, this is undefined. The function value is not defined there. As a matter of fact, the domain of this function is all real numbers except for x equals 0, because that makes the function undefined. But really what the question is all about is, all right, I get it. I understand the function's not defined there, but what would it be if it was defined? And you're going, but it's not defined there. Yeah, but what would it be? And that's exactly what we're trying to find out with a limit. Okay, so I'm going to continue with this particular problem here. And I know I have 0 on the bottom. It's undefined. But what about sine of 0? Because depending on what the top number is here, some interesting things could happen. All right, so I'll use my good old unit circle, probably want a larger one than that. There we go, there we go. And sine is the y-coordinate at 0. So that's, the point 1, 0. The y-coordinate is 0. The sine of 0 is 0. This is a very important ratio, which in calculus we call an indeterminate form. And we're going to be seeing lots of these indeterminate forms, and this is our very first one, 0 divided by 0. Well, when we see numbers, any number divided by itself is supposed to be 1, right? We got 5 divided by 5, pi divided by pi. It doesn't matter, right? It's equal to 1 unless it's 0. 0 divided by 0 is supposed to be undefined, and the picture, as we will see, is much more complicated than that. It's not going to just like, the graph, is it going to approach 1 then? And just have like a little hole there? There's lots of different things that could possibly happen, and our lesson here is to figure out what those could be. It's the whole idea behind a limit. All right, whoa, that was a preview of what's to come here, and I didn't want to show you that. So let's go back to the slideshow here, warm up 2. On your graphing calculator this time, we wanted to graph that function, f of x is equal to sine x over x, and I'll go ahead and graph that, bam. The question is asking, as x gets close to 0, what does f of x approach? So on my graph here, we want to know as x gets closer to 0, and when it gets closer to 0, it can approach it from either side, right? The negative side or the positive side. So it's like this. As x gets closer and closer to the y-axis, what's the graph actually getting close to? What is f of x approaching? I know there's actually a hole there. I can't see it. It's so small I can't see it. But if I were going to like put a little open circle around it, what y-coordinate does it look like it's getting close to? And so it looks like it's getting close to the number 1. And that is the idea behind a limit here. So it says, and this is how I may have written it in pre-cal, as x approaches 0, that's how I would read that arrow there, as x approaches 0, f of x approaches 1, and that's called a limit. All right, so our new notation in this lesson looks like this. I read that as the limit as x approaches 0 of, and then inside the limit, we put the actual function that we're trying to find the limit of, sine x over x is equal to 1. Now, technically speaking, since I found this value from a graph, I wouldn't actually use the equal sign. I should use an approximately equal sign because I'm not real sure without actually analytically deriving that. Look at that, 10%. Okay, so the lim, L-I-M, is just short for limit, and we always put right underneath it what x value, what input value are we trying to get close to, and the answer to that is what the output value is trying to approach, right? So this is the first part of that objective where we're trying to approximate the value of a limit by looking at a graph. And there's another way to do it, and that's numerically. And so on the third warm-up question, it asks you to look at a table of values for f of x is equal to sine x over x. And then can we do the same kind of thing? So let me turn this calculator on, boop, and let's call up the graph screen there, or the table screen, second graph, right? And now, whenever you ordinarily hit your table, it's already populated for you, but we will learn in the course of this lesson how to populate it ourselves so we can choose our own numbers. And so here's a good choice of numbers so that we can see that the numbers are getting close to 0 from the positive side and from the negative side. And I know right there at 0, we can see that there's an error because it's undefined there. But look at the numbers that are really close to it, 0.99998 on both sides of it. It's getting super close to the number 1. All of this is evidence to suggest that that's what the value of the limit is. So again, no, are you kidding me? After all of that trouble, that plus battery dying, no, I'm not standing for this. I'm not re-recording this video for the 14th time. Anyway, yes, so as x approaches 0, f of x seems to be approaching the number 1, and here we go again with our limit notation. And I'll read it off for you one more time. The limit as x approaches 0 of sine x over x is equal to 1, which is simply saying that the y values for that function are getting close to 1 as the x values are getting close to 0. And that brings us to our first objective here, being able to estimate limits both graphically and numerically. And so we'll go through in the second video here how to systematically approach those two things.